Okay, so in my previous screencast, what I said is the energy cost of dehydrating a potassium ion is compensated by the favorable interactions with the selectivity filter. So since the resolvation of potassium is greater than the desolvation energy required, the potassium ion can flow through the channel. But why is the selectivity filter selective for potassium? Why can't, say, for example, sodium pass through the potassium channel? Well, the answer is because sodium is too small to interact favorably with the selectivity filter. So how does that work? So this is potassium in water. See, it's hydrogen bonded to water because it is positively charged. Therefore, it can hydrogen bond to the partially negative charges on oxygen. This is sodium in water. Sodium can also hydrogen bond to water because it is positively charged, and it can bond to the delta negative charge on the oxygen. But look at the potassium ion in the potassium channel pore. It can also bind to the residues in the pore because it's big enough. But sodium is too small. It can only bind with a few residues and not the other. And that doesn't give it enough binding energy to allow it to be transported or flow passively through the channel. So in the case of sodium, the desolvation energy, or the energy required to break the water shell, is much more than the resolvation energy, because sodium cannot bond properly or make bonds properly with the selectivity filter. So the energy required is much more than the actual energy input. Therefore, the sodium ion cannot pass through the potassium channel. If it were bigger, it could bond here with all of the molecules, and it would be able to pass through. But since it's not bigger, it doesn't have enough binding energy to offset the bond breaking energy of getting rid of the water shell. And that's why sodium cannot pass through the potassium channel. It can go in a little bit, but once it reaches the selectivity filter where the channel narrows, it cannot go in further. So you can see, first of all, the channel is 10 angstroms wide, so sodium can go up to here, but it gets stuck at the selectivity filter because it's too small to bond with the residues in the selectivity filter. Therefore, it cannot flow through the channel. It just flows back out again, and the potassium channel remains selective for potassium because of this selectivity filter. Okay, that's all for now. Have fun studying. I will see you in class next week.